that states there is a stable, positive long-run link between the growth rate of output and the growth rate of labor productivity. The simplest mathematical expression is where P is the growth rate of labor productivity, output per worker. Q is the growth rate of total output or value added. B is the Verdoorn coefficient, typically estimated to be around 0.5. Intuitive discussion. The core intuition behind Verdoorn's law is that demand-led output growth is itself a driver of supply-side efficiency gains, productivity. In contrast to neoclassical growth models, like Solo, where productivity growth is often assumed to be an exogenous, external force, manna from heaven, Verdoorn's law suggests that productivity is endogenous. It is generated from within the economic process itself. The underlying reasons for this self-reinforcing process are generally categorized as increasing returns to scale. 1. Dynamic economies of scale, learning by doing, the Adam Smith effect, intuition. When a firm or industry expands its production rapidly, high Q, it provides more opportunities for workers and managers to learn new, more efficient methods. This is learning by doing. The very act of producing more, faster, generates the knowledge needed to do it better. Mechanism. Higher output means more production runs, forcing management to address bottlenecks, refine assembly lines, and reorganize the factory flow. This constant pressure and repetition lead to irreversible efficiency gains, which manifest as higher labor productivity, P. Example. A company launches a new model of smartphones and experiences a huge surge in demand, high Q. In the first month, workers are slow and errors are frequent. By the sixth month, the volume of production has forced the company to install automated machinery, streamline the parts delivery process, and specialize worker tasks on the assembly line. Output doubled, but the number of workers hired only increased by 50%, meaning labor productivity increased. Even if demand falls later, the company keeps the better assembly line and knowledge gained. 2. Static economies of scale, indivisibilities and overhead costs. Intuition. Many predictive resources are lumpy, indivisible, or represent a fixed overhead cost that must be paid regardless of the output level. As production volume increases, these fixed costs are spread over more units, lowering the average cost and increasing apparent productivity. Mechanism. Fixed costs like machinery, specialized infrastructure, e.g., a massive steel mill, or R&D departments do not scale directly with output. When output grows, the amount of labor needed per unit of output drops because the existing capital is utilized more intensively. Example. A pharmaceutical company invests in a $10 million automated packaging machine. If it produces 1 million boxes of medicine, the fixed cost per box is $10. If a demand boom pushes output to 2 million boxes, the fixed cost per box drops to $5, resulting in a measured increase in labor productivity. Fewer workers are needed relative to the total output. Cumulative causation. Verdoorn's law forms the basis for theories of cumulative causation, as championed by Nicholas Kaldor. The cycle is, an initial increase in demand, e.g., a successful export drive, leads to higher output growth, Q. Higher output growth induces higher productivity growth, P, via the mechanisms described above. Higher productivity growth reduces the cost of production and/or increases competitiveness, lower prices, which fuels further exports and further increases in demand. This creates a virtuous circle for fast-growing economies, and conversely, a vicious circle for slow-growing ones, leading to potential divergence between countries.